Imagine being pinned down in the pitch black of a hostile night. The enemy is advancing, their muzzle flashes lighting up the tree line just a few hundred yards away. Your radio operator is screaming for support, but the fast movers, the fighter jets, are struggling to acquire targets in the dark. Then you hear it. It is a low, steady, unmistakable drone echoing from the clouds, sounding less like an aircraft and more like a slow-moving freight train in the sky. Suddenly, a solid beam of red tracer fire erupts from the heavens, followed by a deafening roar that shakes the earth, and an entire grid square of enemy positions is simply erased from existence. The infantry has a saying that the night belongs to the enemy, but that is only true until the AC-130 Spectre arrives. Welcome back to the War Room, where we dissect the machines, the tactics, and the cold, hard math of military supremacy. If you have ever called in close air support, or if you just want to understand the terrifying physics behind the most heavily armed aircraft in history, hit that subscribe button and sound off in the comments below. Today we are pulling back the classified curtain on the flying fortress that rewrote the rules of engagement. We are talking about the AC-130 Gunship, a platform that took the basic concept of a cargo plane and turned it into a weapon of mass deletion. To understand how a slow, unarmored transport plane became the most feared predator in the night sky, we have to rewind the clock and look at the strategic nightmare of close air support, or CAS. The fundamental problem of CAS has always been the battle against time and physics. During the Second World War, if American troops were pinned down in the hedgerows of Normandy, they could call in P-47 Thunderbolts. The Thunderbolt was a beast, heavily armed and rugged. But traditional fighter bombers fly fast. They have to, in order to survive. A fighter jet comes in at 300 to 500 miles per hour, drops its ordnance, and has to pull away, circle back, and reacquire the target. It is a fleeting moment of violence. The loiter time, the actual amount of time the aircraft can spend over the target delivering continuous fire, is measured in mere seconds. This pass and extend tactic is great for taking out a bridge or a bunker complex, but it is terrible for suppressing a sustained infantry assault or hunting moving convoys at night. We saw this limitation again in the Korean War. Fast-moving jets like the F-80 Shooting Star were great for dogfights up at Mig Alley, but down in the dirt, trying to stop massive waves of infantry in the freezing mountains, they were simply too fast to provide persistent, pinpoint fire. The ground commanders needed something that could hang around. They needed a platform that acted less like a cavalry charge and more like a naval broadside. Think of the USS New Jersey off the coast of Okinawa or Lebanon, parking itself offshore and raining continuous, methodical artillery fire for hours. The Air Force needed a flying battleship. Fast forward to the early 1960s, and the United States found itself sliding into the quagmire of Vietnam. The strategic landscape was entirely different from the plains of Europe or the frozen ridges of Korea. The enemy was the Viet Cong and the North Vietnamese Army, and their primary lifeline was the Ho Chi Minh Trail. This was not a paved highway. It was a sprawling, thousands of miles-long network of dirt paths, hidden under triple canopy jungle, winding through mountains and valleys. The NVA moved their supplies almost exclusively at night to avoid American air power. Trying to hit a moving convoy of camouflaged trucks in the jungle with a fighter jet at night is like trying to thread a needle while riding a roller coaster blindfolded. The fast movers were dropping thousands of tons of bombs, but the logistical flow of the enemy barely slowed down. The United States military-industrial complex, the most powerful economic engine on the planet, was being frustrated by bicycles, dirt roads, and the cover of darkness. This brings us to a rhetorical question. How do you solve a problem where speed, the very thing that keeps combat aircraft alive, is actually your biggest disadvantage? The answer came from a seemingly crazy idea called Project Tail Chaser, spearheaded by a brilliant Air Force captain named Ronald Terry. Terry looked at a maneuver that had been around since the early days of flight, the pylon-turn. If an aircraft banks into a turn and flies in a continuous circle around a fixed point on the ground, the center of that circle remains stationary relative to the aircraft. If you mount weapons on the side of the plane, pointing down and inward, you can pour a continuous, uninterrupted stream of fire onto a single point for as long as you have fuel and ammunition. It was the same geometry used by Native American light cavalry circling a wagon train, but applied in 3 dimensions at 10,000 feet. Terry and his team first tested this concept by strapping electrically driven miniguns into the cargo door of an old World War II-era C-47 Skytrain. They called it the AC-47 Spooky, famously known as Puff the Magic Dragon. It was a revelation. A single AC-47 could orbit a besieged Special Forces camp at night and lay down a cone of fire so dense it looked like a solid red waterfall. But the C-47 was a relic. It was too small, too slow, and could not carry enough weight. The NVA quickly adapted. They started moving heavy anti-aircraft artillery, or AAA, down the trail. They brought in Soviet-built 37mm and 57mm radar-guided flak cannons. The AC-47, with its thin aluminium skin and limited altitude, was suddenly flying into a meat grinder. The Air Force needed a bigger, badder, and much tougher platform. This is where the strategic force comparison between American industrial doctrine and Soviet military doctrine becomes fascinating. Soviet doctrine heavily favored ground-based air defense systems, creating overlapping umbrellas of surface-to-air missiles, and AAA to deny airspace. Their approach to close air support relied on heavily armored flying tanks, like the Ilyushin Il-2 in World War II, or the Su-25 Frogfoot later on, designed to fly low, take hits, and smash through enemy lines. The United States, however, relied on absolute air supremacy. American doctrine dictated that you own the sky first, and then you use that sky to systematically dismantle the enemy on the ground. To counter the growing Soviet-backed air defenses on the Ho Chi Minh Trail, the United States did not build a flying tank. Instead, they took their premier tactical airlifter, the Lockheed C-130 Hercules, and decided to turn it into a flying sniper tower that shoots artillery shells. The C-130 Hercules was an engineering marvel of the 1950s. Designed by Lockheed Martin, it was built to carry heavy loads into short, rough dirt strips. It had 4 powerful Allison T-56 turboprop engines, giving it massive lift capability and a maximum takeoff weight of over 155,000 pounds. It was rugged, reliable, and most importantly, it had a cavernous cargo hold. Captain Terry and the engineers at Wright-Patterson Air Force Base looked at this cargo hauler and essentially asked, what if we made it very angry? The transition from the AC-47 to the AC-130 was not just an upgrade, it was a quantum leap in lethality and industrial integration. Let us look at the arsenal they managed to cram into the left side of this aircraft, because it perfectly illustrates the overwhelming industrial capacity of the United States. First, they installed 4 20mm M61 Vulcan rotary cannons. These are the same Gatling guns used on fighter jets, capable of firing up to 6,000 rounds per minute. But the engineers knew that 20mm rounds lose their punch at higher altitudes, and the AC-130 needed to fly higher to avoid the NVA flak. So, they went looking for a bigger hammer. They found it in the 40mm Bofors cannon. This is a fascinating piece of historical recycling. The Bofors was originally a Swedish-designed anti-aircraft gun used extensively by the US Navy in World War II to shoot down Japanese kamikazes. The Air Force took these naval deck guns out of mothballs, modified them, and mounted them pointing out the side of an airplane. The 40mm fired a massive 2-pound high-explosive shell that could punch through jungle canopy and obliterate a truck engine block in a single hit. But even the Bofors was not enough. The NVA started digging their tanks and supply bunkers deeper. The Air Force needed bunker-busting capability. So, they did something that sounds like it was written in a Hollywood action script. They took a 105mm M102 howitzer, a standard piece of United States Army field artillery, and bolted it inside the airplane. Let that sink in for a moment. This is a cannon that fires a 33-pound artillery shell. On the ground, it takes a crew of 8 men to operate, and when it fires, it kicks up a cloud of dust and digs its spades into the earth to absorb the massive recoil. Which brings us to another rhetorical question. How do you compensate for a 105mm cannon kicking back with thousands of pounds of force inside a pressurized aluminum tube, flying at 300 miles per hour? The answer is brilliant engineering. The engineers designed a specialized recoil mechanism that absorbed the shock, transferring it safely through the airframe without ripping the fuselage apart. They mounted the gun on a track system so it could be manually loaded by the crew, who were essentially acting as airborne artillerymen, wrestling heavy brass casings in the dark, freezing, unpressurized rear of the aircraft. This marriage of aerospace engineering and heavy ground artillery created a platform that had no equivalent in the Soviet inventory or anywhere else in the world. But firepower is useless if you cannot see the target. The strategic genius of the AC-130 was not just its guns, it was its sensors. The United States defense industry was pioneering the early stages of the digital battlefield. While the NVA relied on camouflage and darkness, the AC-130 was equipped with early-generation forward-looking infrared, or FLIR. This allowed the crew to see the heat signatures of truck engines, campfires, and even human bodies through the pitch-black night. They also installed low-light level television cameras. Perhaps most incredibly, they deployed a highly classified sensor known as the Black Crow. The Black Crow was an ignition sensor. It could pick up the electromagnetic interference generated by the spark plugs of Soviet-built ZIL trucks driving down the Ho Chi Minh Trail. The NVA drivers would turn off their headlights to hide in the dark, but the moment their engine was running, the AC-130 could track them through the clouds. This created a terrifying disparity in the force comparison. On one side, you had a peasant army relying on brute force logistics, moving supplies by hand and truck through a malaria-infested jungle. On the other side, you had an airborne Leviathan, loitering at 10,000 feet, using thermal imaging and electromagnetic sensors to hunt them in the dark, and raining down 105mm artillery shells with pinpoint precision. The AC-130 essentially turned the Ho Chi Minh Trail into the world's most dangerous shooting gallery. But this technological supremacy did not mean the skies were safe. The NVA were not passive targets. They were deeply entrenched, highly disciplined, and heavily armed. As the gunships began to take a massive toll on the supply lines, the North Vietnamese command realized they had to kill the Spectre. They began dragging heavy radar-guided anti-aircraft guns to the top of the mountains, creating flak traps specifically designed to ambush the slow-orbiting cargo planes. The skies over Laos and Cambodia became a deadly arena of cat and mouse. The AC-130 had the firepower to destroy anything it could see, but its massive size and predictable circular flight path made it vulnerable. The crew had to rely on electronic countermeasures, intense coordination, and nerves of absolute steel to survive. They were flying an unarmored fuel tank loaded with thousands of rounds of high explosives directly into the teeth of the most concentrated air defense network in the history of guerrilla warfare. The drawing board theories and the engineering miracles were about to be tested in the brutal, unforgiving reality of midnight combat operations. The foundation was laid, the weapon was forged, and the crews were trained. But surviving the night would require a level of tactical execution that pushed the limits of human endurance. Stepping inside the cargo hold of an AC-130 during a live combat orbit is like walking into the gun deck of a 19th century ship of the line in the middle of a hurricane. While the pilot and co-pilot sit in a relatively quiet, high-tech cockpit managing the flight profile, the back of the aircraft is a blue-collar, ear-shattering factory of violence. The temperature at 10,000 feet often drops well below freezing, hovering around 10 degrees Fahrenheit, and the rear of the aircraft is unpressurized. The gunners wear heavy flight jackets, oxygen masks, and dual-layer ear protection just to survive the environment. Every time the 105mm howitzer fires, a massive concussive shockwave ripples through the aluminium airframe, instantly followed by the acrid, choking smell of burned cordite filling the cabin. These aerial artillerymen are not just pushing buttons, they are engaging in grueling physical labor, manually wrestling 33-pound brass shells in the dark, slipping on spent casings and slamming fresh rounds into the breech while the aircraft bounces through violent, turbulent air. It is a level of synchronized physical teamwork that mirrors the legendary B-17 Flying Fortress cruise over Germany in 1943, where survival depended entirely on every man executing his job flawlessly in a freezing, flak-filled sky. But brute force is nothing without precision, and the true lethal genius of the AC-130 lies in its fire control system. To understand the tactical advantage of this aircraft, we have to look at the terrifyingly complex mathematics of the pylon-turn. When the gunship banks into its left-hand orbit, the guns are fixed in place, pointing down and to the side. The pilot is not actually aiming the weapons with a traditional crosshair. Instead, the Fire Control Officer, or FCO, acts as the conductor of this deadly orchestra. The FCO sits at a console staring at sensor feeds, feeding data into a ballistic computer. This computer must constantly calculate an insane number of variables to achieve a first-round hit. It factors in the airspeed of the aircraft, which is usually around 300 miles per hour. It calculates the altitude, the barometric pressure, the humidity, and the ambient air temperature. It measures the wind shear at multiple different altitudes between the aircraft and the ground. It even factors in the Coriolis effect, the actual rotation of the Earth beneath the bullet during its flight time. So how do you hit a moving tank with a howitzer from 2 miles up in the sky while flying through a thunderstorm? You trust the math, you trust the sensors, and you rely on an alignment system where the computer tells the pilot exactly what microscopic adjustments to make to the flight path to bring the impact point directly onto the target. When the system is locked, the FCO authorizes the shot, and the resulting accuracy is staggering. A skilled crew can place a 105mm high-explosive shell through the roof of a moving vehicle from over 10,000 feet away. This capability fundamentally changed the doctrine of close air support. Unlike a fighter jet that drops a bomb and leaves, the AC-130 can loiter over a target area for hours, providing a persistent, terrifying umbrella of overwatch. If ground troops take fire from a tree line, the gunship does not need to do a 5-mile sweeping turn to re-engage. It just tightens its orbit, shifts its sensors, and unleashes a continuous broadside, much like the USS Constitution pouring cannon fire into a British frigate during the War of 1812, but executed from the stratosphere. However, this incredible tactical advantage comes with severe, inherent vulnerabilities. The AC-130 is a massive, 4-engine cargo plane with the radar cross-section of a flying barn. It is slow, it is unmaneuverable by fighter standards, and its predictable circular flight path makes it an incredibly easy target for advanced air defense systems. The doctrine is clear. The Spectre owns the night, but it cannot survive in contested daylight. This vulnerability was put to the ultimate test during the Easter Offensive in April of 1972. The North Vietnamese Army launched a massive conventional invasion into South Vietnam, abandoning guerrilla tactics and rolling columns of Soviet-built T-54 tanks down Route 13 toward the city of An Loc. American ground troops had largely been withdrawn, leaving a small number of U.S. military advisors pinned down with the South Vietnamese Army, facing a mechanized onslaught they had no weapons to stop. The defense of An Loc fell heavily on American air power, and the AC-130s were called in to break the back of the armored columns. Night after night, the gunships arrived over the besieged city, their sensors cutting through the smoke and jungle canopy to spot the hot engine blocks of the T-54s. The 40mm Bofors cannons were highly effective at stripping away the infantry riding on the tanks, but it was the 105mm howitzer that proved to be the ultimate tank killer. An armor-piercing shell, dropping from a steep parabolic angle, hits a tank on its top turret, where the armor is the thinnest. Entire NVA armored columns were halted, left burning on the dirt roads as the gunships systematically dismantled them from above. But the NVA had brought a new, deadly toy down the trail, the SA-7 Strela. This was a shoulder-fired, heat-seeking surface-to-air missile that completely changed the threat matrix for the slow-moving gunships. Suddenly, the crews orbiting An Loc were not just dodging dumb flak, they were fighting off guided missiles, tracking their engine exhaust. The crews had to constantly scan the black jungle for the telltale flash of a missile launch, ready to violently break their orbit and dump defensive flares, knowing that every second they spent evading was a second the men on the ground were fighting for their lives without air support. This delicate balance between providing support and surviving the environment defined the operational reality of the AC-130 for decades, leading to a continuous evolution of tactics and technology. By the time the United States launched Operation Desert Storm in January of 1991, the platform had evolved into the AC-130H Spectre, boasting upgraded sensors and electronic countermeasures. The Iraqi army, boasting the fourth largest military in the world, possessed a formidable integrated air defense network. The coalition forces rapidly established air supremacy, but the ground war presented chaotic, unpredictable threats. On January 29th, Iraqi armored divisions launched a surprise offensive across the Saudi Arabian border, seizing the coastal town of Khafji. Small teams of US Marines and Navy SEALs were trapped behind enemy lines in the city, calling desperately for fire support as Iraqi mechanized infantry closed in on their positions. The AC-130s were dispatched to orbit Khafji, and they did exactly what they were built to do. They rained hellfire down on the Iraqi armor, breaking up troop formations and destroying armored personnel carriers, creating a wall of steel around the trapped American special operators. But as the hours dragged on, a fatal variable entered the equation. The rotation of the Earth was bringing the sun up over the Persian Gulf. The golden rule of the gunship community is that you must be wheels up and heading home before dawn, because a slow-moving cargo plane silhouetted against a morning sky is a sitting duck. What happens when the ultimate creature of the night is caught lingering in the dawn? On the morning of January 31st, 1991, an AC-130H with the call sign Spirit 03 was operating over Khafji. The crew of 14 men knew the sun was rising and they were ordered to return to base. But a Marine ground controller transmitted that they were taking heavy fire from an Iraqi missile battery and needed one last fire mission. The crew of Spirit 03 made the ultimate sacrifice. They chose to stay, banking into one final pylon-turn in the growing daylight to protect the Marines on the ground. As they leveled out to fire, an Iraqi soldier on the ground fired a single SA-7 heat-seeking missile. The missile tracked the infrared signature of the Allison turboprop engine and detonated. The massive aircraft suffered catastrophic damage, plunging into the waters of the Persian Gulf, and all 14 crew members were killed in action. It was a devastating blow that proved, with brutal finality, that no amount of firepower can overcome the fundamental physics of a slow airframe in a daylight combat zone. The loss of Spirit 03 forced the Pentagon to realize that if the gunship was going to survive the battlefields of the 21st century, it would need a technological overhaul so profound that it would blur the line between an aircraft and a flying supercomputer, setting the stage for a new generation of warfare where the shadows themselves would be weaponized. The technological overhaul, born from the ashes of Desert Storm, resulted in the AC-130U Spooky, a platform that transformed the raw, brute force of the Vietnam era into a surgical instrument of modern warfare. The Air Force realized that surviving the modern battle space required more than just flying at night. It required seeing the enemy before they even knew they were being hunted. The Spooky was equipped with an all-weather synthetic aperture radar, allowing the crew to track targets through heavy cloud cover, dust storms, and the thick black smoke of burning oil wells. They upgraded the fire control system so extensively that the aircraft could now track and engage two separate targets at the exact same time, using two different weapons with two different ballistic trajectories. They replaced the twin 20mm Vulcans with a single 25mm GAU-12 equalizer, a 5-barrel Gatling gun that fired a heavier, more destructive, depleted uranium shell. But the 40mm Bofors and the massive 105mm howitzer remained, because no amount of microchips can replace the sheer kinetic devastation of heavy artillery. This brings us to a critical tactical lesson regarding the application of overwhelming firepower in dense urban environments. By the time the United States entered the global war on terror, the battlefield had shifted from the open deserts of Iraq and the jungles of Vietnam to the claustrophobic concrete canyons of cities like Mogadishu, Fallujah, and Ramadi. Urban warfare is a three-dimensional nightmare for an infantryman. Threats can come from rooftops, basements, sewer grates, and every window in a 10-story apartment building. How do you provide close air support when the enemy is separated from friendly forces by only a single cinderblock wall? If you drop a 2,000-pound bomb from an F-15 Strike Eagle, you destroy the enemy, but you also level the entire city block, potentially killing the very troops you are trying to protect. This is where the AC-130 proved its absolute strategic indispensability. During the Second Battle of Fallujah in November 2004, American Marines and Army infantry were engaged in the heaviest urban combat since the Battle of Hue City in 1968. The insurgents had fortified houses, creating fatal funnels and kill zones. The AC-130s orbiting above the city acted as the ultimate high ground. We can draw a direct historical comparison here to the naval gunfire support provided by American destroyers during the amphibious assault on Iwo Jima in 1945. At Iwo Jima, destroyers would sail dangerously close to the shore, using their 5-inch guns to directly blast Japanese pillboxes that were pinning down the Marines. In Fallujah, the AC-130 was that destroyer in the sky. A Joint Terminal Attack Controller, or JTAC, embedded with the infantry on the ground, would radio the gunship, providing coordinates down to the specific window of a specific building. The gunship crew, staring through high-definition infrared sensors, could see the heat signatures of the insurgents inside the room. They would then calculate the angle, factor in the wind, and fire a single 105mm shell through the roof, detonating inside the room and vaporizing the threat, without collapsing the adjacent building where friendly troops were taking cover. This level of precision fundamentally alters the political and psychological dimensions of warfare. From a political standpoint, modern conflicts are fought under the constant scrutiny of the global media and strict rules of engagement. Collateral damage is not just a human tragedy, it is a strategic liability that can turn the local population against the occupying force and fuel insurgent recruitment. The AC-130, despite being one of the most destructive conventional weapons in the American arsenal, is, ironically, also one of its most precise. The crew has eyes on the target for the entire duration of the engagement. Unlike a drone operator sitting in a trailer in Nevada or a bomber pilot dropping GPS-guided munitions from 30,000 feet, the gunship crew is physically present in the battle space. They can see the women and children fleeing a compound. They can see if an insurgent drops his weapon and surrenders. They can abort a fire mission a fraction of a second before pulling the trigger if the situation on the ground changes. But this capability comes at a staggering logistical and economic cost. The military-industrial complex has never met a problem it could not solve by throwing $1 billion and a massive pile of high explosives at it. And the latest iteration, the AC-130J Ghostrider, is a prime example. A single Ghostrider costs well over $115 million. It requires a highly specialized crew of officers and enlisted personnel, all of whom require years of expensive continuous training. Operating these massive 4-engine aircraft out of forward operating bases in places like Afghanistan or Iraq requires a monumental logistical tale. You have to transport thousands of gallons of specialized aviation fuel, sensitive electronic replacement parts, and heavy, bulky 105mm artillery shells across the globe. You are essentially maintaining a flying battleship in the middle of a desert. When you look at the economics of counterinsurgency, the math becomes highly asymmetrical. The United States is spending tens of thousands of dollars per flight hour, burning through highly expensive aviation fuel and precision munitions to hunt down a small group of insurgents armed with $200 AK-47s and homemade explosives. This economic disparity raises a fundamental strategic question. In an era where cheap disposable suicide drones and loitering munitions are dominating the battlefields of Eastern Europe and the Middle East, is a massive, manned, slow-moving gunship a relic of a bygone era? The Pentagon's answer to this was to turn the Ghostrider into a hybrid weapons truck. They replaced the 25mm and 40mm cannons with a single, highly accurate 30mm GAU-23 Bushmaster chain gun. More importantly, they integrated precision-guided munitions directly onto the wings and the rear cargo door. The AC-130J can now launch AGM-176 Griffin missiles and drop GBU-39 small-diameter bombs. This allows the gunship to strike targets from miles away, outside the range of shoulder-fired anti-aircraft missiles, without ever having to enter a traditional pylon-turn. There was even a serious debate within the Air Force about removing the 105mm howitzer entirely to save weight and make room for more lasers and smart bombs. However, the ground commanders and the infantry community fought bitterly to keep the big gun, and their reasoning brings us to the psychological aspect of warfare. Smart bombs are efficient, but they are sterile. A laser-guided missile drops silently from the sky and detonates. The 105mm howitzer, on the other hand, is an instrument of psychological terror. When an AC-130 fires its main gun, the supersonic crack of the artillery shell breaking the sound barrier arrives just before the massive explosion. For the enemy on the ground, it is a terrifying, inescapable barrage. We can compare this to the psychological impact of the Stuka dive bomber used by the German Luftwaffe in the early days of the Second World War. The Stuka was equipped with wind-driven sirens called the Jericho trumpets, which produced a screaming wail as the aircraft dove, designed specifically to shatter the morale of the troops below. The AC-130 does not need a siren. The low, ominous drone of its 4 turboprop engines circling in the pitch-black sky is enough to make seasoned insurgent fighters abandon their positions and flee into the night. It is the sound of inevitable, incoming violence. Yet the strategic limitations of the platform remain absolute. The AC-130 can only operate in permissive environments, where the United States has total air supremacy. If you put an AC-130 into a sky contested by modern peer adversaries with advanced surface-to-air missile networks and fifth-generation fighter jets, the gunship would not survive for 5 minutes. It is a highly specialized tool designed for a very specific type of asymmetrical warfare. It relies heavily on an intricate web of intelligence, surveillance, and reconnaissance. The gunship rarely hunts alone anymore. It is usually fed targeting data by a constellation of high-altitude drones, like the MQ-9 Reaper, which paint the targets with lasers, allowing the AC-130 to roll in and deliver the finishing blow. It is a seamless integration of unmanned intelligence and manned kinetic execution. War is ultimately a brutal equation of time, mass, and energy. And for over half a century, the AC-130 has been the ultimate variable in that equation, bending the rules of physics and aerospace engineering to deliver ground-shaking artillery fire from the clouds. It stands as a monument to American industrial might and tactical ingenuity, a slow-moving cargo plane that somehow became the undisputed king of the night sky. Now it is your turn to weigh in on the future of close air support. As modern air defense systems become cheaper and more advanced, What do you think will replace the AC-130 gunship in the next 50 years? Is it A, swarms of low-cost unmanned combat drones that can loiter indefinitely? Is it B, stealth fighter jets providing surgical, high-altitude strikes to avoid detection? Or is it C, the continuous upgrading of massive manned gunships equipped with directed energy weapons and lasers? Let us know your tactical assessment in the comments below, and do not forget to subscribe for more deep dives into the machinery of war.